So, hi guys, this is Dr. Edwards again. I want to give some suggestions for the solution of the exercise questions in Chapter 14. Okay? So, the first homework assignment question is number one. What caused ionization to occur in the upper atmosphere? First of all, ionization of the air molecules does indeed occur. And it occurs because incoming solar radiation from the sun cause the molecules to ionize. And that radiation, X rays and gamma rays, those are the primary two that cause ionization of the molecules in the upper atmosphere. Number two, suppose you're climbing in an airplane that has no altimeter. How could you tell when you are approaching the top of the troposphere? One way that you could do that is you need to have an outside thermometer. And the layers of the atmosphere are designated according to change in temperature. The lowest part of the atmosphere is the troposphere, and the temperature decreases as you go from the troposphere up to what's called the tropopause, Tropo um, uh, Pause, tropopause. So at the tropopause, the temperature remains constant for maybe 2 miles or so. And that's the way that you can tell that you have reached the top of the troposphere, is when the airplane begins to enter into the tropopause and you find out that there's no more change in the temperature. Okay, so that's the way you do it. Need a thermometer, and you can tell when you have reached the top of the troposphere by the temperature remaining constant. Number three, and now this one talks about the pauses. So the tropopause, the stratopause, the mesopause are relatively upper boundaries of the troposphere, the stratosphere, and the mesosphere. What is the characteristic of the air temperature at each of these boundaries? As I just said when I was looking at problem number two, the temperature is relatively constant in each of the pauses. Okay, so that's it. That's what you need to tell me. That's what is the case, and that's why we call them pauses, because the temperature is changing, either increasing or decreasing in each of the spheres, but yet during the pauses, the temperature remained constant for several miles during uh, that particular pause. Number four, what would happen if ozone were to disappear from the upper atmosphere, from the lower atmosphere? And this is an excellent question. The ozone is definitely needed in the upper atmosphere, and the part of the atmosphere where it's located is the stratosphere. It is the stratosphere, back to problem number three, stratosphère. There is no wind in the stratosphere. All the wind, all the storms, everything that happens to us here on the planet happen to us in the troposphere. But in the stratosphere, there is no motion of the molecules of the atmosphere. So we have this layer of ozone in the upper atmosphere that uncovers the earth like a sheet, and therefore it absorbs incoming solar radiation, particularly ultraviolet radiation, is absorbed by the ozone, and therefore the ozone doesn't reach in great proportion to sea level where we live, and therefore it is helpful to us. It lessens the probability of skin cancer. However, we don't need ozone in the lower atmosphere. Ozone in the lower atmosphere helps to lead to smog, and smog then cause upper respiratory illnesses, okay? So we want to keep ozone in the upper atmosphere, but we do not want to have ozone in the lower atmosphere. Okay, that takes care of that. Let me see one other question here. Hold on for a moment. Number 12. What do high altitude clouds consist of? Low altitude clouds. I need you to know this. There are three levels of clouds in the atmosphere. There are 5 clouds at the lower level, and I'll point them out to you in another video. And there are 2 mid-level clouds called altos, and then there are 3 high-level clouds. So there are 10 types of clouds that I want you to know of. Now, what differentiates them is that the clouds in the upper atmosphere are really sheets of ice in air. So they are really sheets of ice in air. Different from the ice in your parents' refrigerator, because there you have ice in water. So it's solid ice in a liquid. But here you have sheets of ice in air. The lower altitude clouds, though, consist of microscopic droplets of water in air. So low-level clouds are water droplets, fine water droplets in air. That's what they are. But upper-level clouds are sheets of ice in air. And number 13, what initiates the fall of rain from a cloud and the fall of snow? It is the sudden cooling. So in a cloud, the water molecule, fine drops of water will circulate up and down in the clouds, and cooling and getting larger as it goes up. So when the droplets move upward in the cloud, they cool even more and they get a little larger each time they cycle. And therefore, at some point, they get large enough from that sudden cooliness that the droplets fall out as rain. If you have that same phenomenon going on in a cloud that can generate snow, the flake go up in the cloud down, but as it goes up, the flake gets heavier, larger, and eventually will fall out as snow. Okay, guys, that's what I wanted to say to you about this information here. Have a good day. Continue to work hard.